What's up, my stat stars? The addition formula is one of the most used formulas in all of probability. It's actually really useful because it has four values. It starts off with the probability of A or B, which equals the probability of A, plus the probability of B, minus the probability of A and B. But there's actually a fifth value they get for free because the opposite of the probability of A or B, or the complement of the probability of A or B, is neither, not A nor B. So you kind of get five things for free when using this formula. So in this video, what I want to do is I want to tackle three problems: an easy one, a medium one, and a difficult one that all involve the use of the addition formula, as well as some other really important properties that it comes to probability. All right, so let's first take a look at the addition formula one more time. So once again, it's the probability of A or B, which equals the probability of A plus the probability of B minus the probability of A and B. All right, the first problem here is an easy one. So if the probability of A is 0.25, the probability of A or B is 0.62, and the probability of both A and B is 0.07, what is the probability of B? Now, the first thing you should recognize is, wow, I got A's, I got B's, I got A or B. Hey, I'm gonna need the addition formula. So let's just get our bearings straight. So first, the probability of A was given to us as 0.25. The probability of A or B was given to us as 0.62. And the probability of A and B was given to us as 0.07. And we're trying to find the probability of B, which we could call X, because we're gonna use some algebra here to solve this. So first, let's start off with the addition formula. Let's substitute in everything we know. The probability of A or B is 0.62. Probability of A is 0.25. Probability of B is what we don't know, so I'm going to call that X. And the probability of A and B is 0.07. All right, so the first thing we do on the right-hand side is combine the like terms. 0.25 and negative 0.07 are like terms. They're just plain old numbers. We can combine them together, get 0.18. Then we're going to subtract the 0.18 to the left-hand side to get 0.44, and boom, we have X, so we now know the probability of B is 0.44. That was an easy problem. All right, this next problem is a medium level. Here we're given some similar information. The probability of A is 0.25, the probability of A or B is 0.62, and we know that A and B are two mutually exclusive events. All right, what is the probability of B? Well, the first thing we got to remember is, what does mutually exclusive event means? It means that the probability of A, it means that A and B cannot happen at the same time, which means the probability of A and B is zero. Because if they can't happen at the same time, there is no overlap, hence the probability of zero. So here's what we know from the sentence. The probability of A is 0.25, the probability of A or B is 0.62, and because they're mutually exclusive, we automatically know that there is no overlap and the probability of A and B equals zero. So once again, we're going to dive right into our formula, plug in everything we know: 0.62 for A or B, 0.25 for the probability of A. We're going to call the probability of B X. And again, we know because they're mutually exclusive, the probability of A and B is zero. So combine like terms, 0.25 combined with 0 is, well, 0.25. Subtract the 0.25 to the other side, and we get X equals 0.37. So we know the probability of B is 0.37. Now that was a medium level because you had to know some additional information about what the heck mutually exclusive means. All right, let's check out a difficult one. Most kids get this one incorrect because, well, they just don't know what to do. Let's walk through it. So once again, the probability of A is 0.25. The probability of A or B is 0.62. But this time we're told that A and B are independent events. What is the probability of B? All right, so we have to figure out, what does it mean when you're independent events? Well, if you learned, you should know that the probability of A and B is equal to the probability of A times the probability of B, only if you have independent events. Otherwise, you got to think conditionally. So here's what we know from this sentence. The probability of A is 0.25, the probability of A or B is 0.62, and because they were independent, that automatically tells us that we could find the probability of A and B by taking the probability of A times the probability of B. Now, we already know the probability of A, that's 0.25, and we don't know the probability of B, so again, we're going to call that X. So the probability of A and B is 0.25 times X. All right, now we're going to substitute everything we know into the addition formula. So the probability of A or B is 0.62, the probability of A is 0.25, the probability of B is X, that's what we're looking for, and remember, the probability of A and B is 0.25 times X. Let me explain that one more time because that's where a lot of kids get tricked. We already knew the probability of A, 0.25, and we know that the probability of A and B, if you're independent, is A times B. So that's how I have 0.25 times X, because remember, X is taking the place of the probability of B. So first, on the right-hand side, we're going to combine like terms. We have a 1x and a negative 0.25x. 1x minus 0.25x is 0.75x. They're like terms. Then we're going to subtract the 0.25 to the left-hand side and get 0.37. And we have one final step, and that's to divide the 0.75 over, and we get 0.493 for x. So the probability of B is 0.493. This is a very difficult problem that a lot of kids get wrong, so make sure you understand all the tiny details that go into getting this problem right. And I gotta be honest, a lot of kids get this wrong, not because of the probability, but because they're bad at algebra. They don't even know that 1x minus 0.25x is 0.75x, but hopefully you do. All right, so those are three very common problems that range from difficulty, easy, medium, and hard. But if you know how to do those problems and you know how to utilize the addition formula, you're going to be golden when it comes to using any type of problem that involves A, B, A or B, A and B. You get the drill. All right, best of luck. Hopefully that made sense.